So more equations. Really what's going on in this little section here is we're showing that all these kind of laws of algebra, they actually just come from these few laws here. Or, sorry, these aren't laws. Well, these are laws, but they're kind of more like little mini theorems. They come from this. Okay, so there's another one here. Why is this one true? We can probably give two reasons again. So the first one is, so starting with the left-hand side here, you could take out the common factor of p up above. So let's say AP plus BP over CP. That we say that there's a common factor of P. So we take out that common factor of P, and we're left with A plus B divided by CP, and then from before you can divide above and below by P, because that's the same as multiplying by 1. So you get A plus B over C. So that's one way of doing it. Alternatively, you could just multiply above and below by P at the start. So you have AP plus BP over CP, and multiply or divide by P. Now dividing by P is the same as multiplying by 1 over P. This red thing, any number divided by itself is 1. So no matter what P is, well, as long as it's non-zero, works like this. So here you've got a sum multiplied by a number. And how does that work? Well, you use distribution. If you have, where's distribution? If you've got a sum multiplied by something, the thing that's multiplying multiplies both of them. So you get 1 over P by AP. Now the thing is, A is multiplied by P, and now you're dividing by P, that'll get rid of the multiplied by P, so you just get A. And similar story, you've got B multiplied by P, and when you multiply by 1 over P, that's the same as dividing by P. You've multiplied by P, divided by P, they undo each other, you just get A plus B. And on the bottom, similar story, C multiplied by P, divided by P, undoes the multiplied by P, you just get C. Okay? So I think maybe this is the easier one. Rather than taking out the common factor, you can just divide above and below. It's the same as this. So this one you can divide above and below by 5. So you've got a sum here to divide by 5. 5x, if you divide it by 5, well, get rid of the multiply by 5, you just get x. And similar story here, you get y, and then 5 divided by 5 is 1. And of course, dividing by 1 is the same as multiplying by 1. That does nothing, so that's actually equal to x plus y. There's nothing you can do here, because if you divide above and below by 5, you have to divide the 2p by 5 as well. So there's all kind of nasty things you could be trying to do, and it doesn't work. Similar story here, you can divide above and below by a. It'll undo the multiplying by a here. It'll undo the multiplying by a here, and a divided by a is 1. Okay. Now this one, this multiplying out, I don't think this is so important for us actually, so I'm going to leave that out. I actually hope that most of these we won't really need so much. Now this we'll have to show. So what's 5z squared? What does squaring mean? Well, squaring means multiplied by itself, isn't it? So this is actually equal to 5z multiplied by 5z. Now we've got a nice little rule here, law, that says the order of multiplication doesn't matter. So you see the z by 5, and actually we're also using associativity, but we won't worry about that. So the z by 5, we can swap them around. We get 5 by 5 by z by z. And what's 5 by 5? 25. And what's z by z? Z squared. So similar story here, 3n squared. 3n by 3n, do the 3 by the 3 is 9, the n by the 9 is n squared. So these are just actually little algebra mistakes that people end up with, but I'd actually be hopeful enough that these just don't really arise for us. Not the mistakes, but the actual problems. Okay. So some just little not notations, some words that you might hear me saying. It'd be nice for you to just, I suppose, if you're confused, it'll say, so when we have a sum of terms, there you go. So say you've got a sum x, 2y, z, these are terms. This thing is called a linear combination. It's just a fancy word actually for a sum. So the things in a sum they call terms. And then factors are the things in a product. So instead of if we added those together, if we multiplied it, you'd call these the factors. There's other fancy words. You call these the summons and these the multiplicans or something. But factors is what it should be. And if the same factor is present in every term, we can factor it out, take it out. And even if there's more than two terms, you can still do this. So for example, x cubed plus x squared minus 5x, we can see a common factor. They're all multiples of x. Now this is x by x by x, and x by x is x squared, so this is x by x squared. This is x by x, and this of course is minus 5 by x, and I'm going to write it as minus, well, just to actually show it off, I'm going to write it as plus x times minus 5, which is the same as minus 5x. So you got this common factor x, it can be taken out. But this is factorizing, it's not going to be such, I don't think it's good, well, we'll need it a little bit. Okay. So I got, when multiplying both sides of an equation by something, because of this, you must multiply each term. So just be careful, if you're multiplying both sides and you got a sum, everything has to be multiplied. If you're squaring a sum, you have to be careful, but I don't think it's actually going to be a big deal for us. But so if you need to square q plus 4, be careful, it's not q squared plus 16. Because you, like, say if you have q plus 4 equal to the square root of x, for argument's sake, and you're looking for x. So I've trained you to get rid of the square root. What's the inverse of the square root? Is a square. So you square both sides. Now what would be a mistake would be to square q and 4. That's not what we're doing. We're not squaring individual numbers, we're squaring both sides. So this should be seen as a single number to be squared. So you don't have q squared plus 16, you should have q plus 4, that number, squared, equal to x. And that's really what this is saying. And a similar story holds with square roots. If you had x squared equal to q squared plus 16, you do the square root of both sides, not the square root of every individual little thing. You have two numbers that are equal, you apply the function to both of them. So the main principle is you can apply any function to an equation as long as you apply the same function to both sides, and you would step by step, as we mentioned in the previous lecture, by applying inverse functions, and the inverses get rid of things you don't want. Okay, so more general guidelines then. Start by removing things that are furthest away from your subject. The subject is usually x, what you're looking to solve, find for. Work in small steps, removing one thing at a time, getting closer and closer to what you're looking for. So the analogy, think of peeling an onion, removing outer layers before getting to the core. So if you're looking for v here, get rid of the 5, that's on the outside, then the g, then the 2, then the v. Sometimes if you go in a different order, it's fine, as long as you're careful in applying your inverse functions, but usually that's going to be the easiest way. It's okay to do many, many small correct steps. It's also okay just to think of the next step instead of having to plan the entire route from start to finish. Okay, so let's see how we get on. And there should be a bit more space here, but there isn't. So we're looking here for v. Okay, so what we want to do is work from the outside. Okay, so what's the first thing you want to get rid of? If you're working from the outside, it's the plus 5. So the function that's applied on the right there is the plus 5 function. And so what we want to do is apply, what's the inverse of plus 5? Is minus 5. And we should apply that to both sides of the equation. So if we apply minus 5 function to both sides, so t minus 5 is t minus 5, and we know that it is the inverse of plus 5, so if we apply it to the right hand side, it'll get rid of it. Okay, now what do we want to get rid of? Now I want to get rid of, remember I'm looking for v, I want to get rid of this g. Now what is this g doing? It's dividing. So the function we want to get rid of now is dividing by g. What's the inverse of dividing? Multiplying by g. So now what we're going to do is we're going to multiply both sides by g. So now here we have to be careful. We've got t minus 5. We need to multiply that by g. If we want maybe just take the whole full side and put it in the bracket. That's probably the safest thing to do. So g times t minus 5. And of course, if we multiply by g, it's the inverse of dividing by g. It'll get rid of the dividing by g, and we'll just be left with 2v. Now what do we want to get rid of? We're looking for v on its own. It is multiplied by 2. So the function that's stopping v from being on its own is multiplied by 2. So apply the inverse of multiplying by 2, which is dividing by 2, or multiplying by a half. Same thing. And do it to both sides. So divide both sides by 2. So we get g times t minus 5 divided by 2, and that dividing by 2 gets rid of the multiply by 2, and we get v. And of course, if that's equal to that, that's equal to that. So if you want to, maybe you're off, and because we read from left to right, v is equal to g times t minus 5 divided by 2. Now you could get rid of things in slightly different order. You could get rid of the g. I think you can nearly do it in whatever order, but this is the easiest way of doing it. I won't dwell on the other possibilities. If I see the other possibilities in your submitted work, if they're correct, I'll say great. If they're not, I'll just show you either the easier way or fix what you're doing, or probably both. Okay. So here's another example. Similar story. What do you want to get rid of first? What's up with the space, maybe? So I'm looking for t here. Okay. That's what I'm looking for. So peeling the onion, what's the thing you want to get rid of first? The minus 2 function. What's the inverse of minus 2? Plus 2. So apply it to both sides. What do we get? So do the plus 2 to q, you get q plus 2. And the plus 2 function is the inverse of the minus 2 function, so that minus 2 is gone. Now what do we want to get rid of? Oh, that 5. What's it doing? Remember, if I'm going too fast, you can pause me. What's that 5 doing? It's dividing. What's the inverse of dividing by 5? Multiplying by 5. Do it to both sides. If you do things this way, things are going to be easier. You might come across some algebra issues like this one, for example. How do I multiply q plus 2 by 5? Well, the easiest thing is just to put it in a bracket. 5 times q plus 2. And of course it gets rid of that dividing by 2. And then finally, I want to get t on its own. What's going on? It's multiplied by 4. So I need to divide by 4. So this is probably something you haven't seen before, because you haven't had the language really of inverses, but this is the way to do things. Divide both sides by 4, 5 times q plus 2, divided by 4, and then dividing by 4 is the inverse of multiplying by 4, so it gets rid of the multiplying by 4. So here you get a similar exercise. Want to get rid of the, it's just doing the first step. Want to get rid of something, what's the inverse, and do it. Okay. And then there's kind of longer equations for you to do. I think we're going to do some more examples now. Okay, here we're going to find the error and then do the correct solution. So what you have to do is just identify which step the mistake is made and do it correctly. So obviously what happened here is someone just decided to move the a and change the sign, which is not maths. The proper way is to identify that what's happened to the x is that it's multiplied by a, and the inverse of multiplying by a is dividing by a, and it divided both sides. So that was the issue there. So that's what that's looking for. Recall, you can apply any function to an equation as long as we apply the same function to both sides. Okay. Variables represent physical quantities, and the symbols are agreed by scientists, blah, blah, blah. Symbols are not necessarily one letter, but often a combination of symbols. In particular actually in programming, where the convention, again, the kind of agreed way of doing things, is not necessarily to use single letters. So like if you're talking about time, a mathematician will use T. A programmer might actually just write T-I-M-E, and it won't mean T by I by M by E. If you write those letters T-I-M-E into, say, Python, it'll see it as a single variable. Okay. Right. So off we go. So every time we're going to look at the equation, cop on what we're looking for, and get rid of stuff. Okay? So here's solve for m. So this is what we're looking for. Now, here's where one of the laws actually, the really obvious laws to me, can actually help a little bit. So I've got two numbers here, c and delta t. C and delta t is actually a single number. It's kind of an obvious thing to say, but look, it says it there. If you multiply two numbers together, you get another one. So if you want, if that's a number you want, it's just, you can get rid of that number. It's fine. It's two numbers multiplied together is 5 by 6 is whatever, 30 is the number. So m is multiplied by this. So what we want to do is we want to get rid of multiplied by c delta t. So we apply the inverse of multiplying by that, which is dividing by that. So we divide both sides by c delta t. And we do it to both sides. We get q divided by c delta t. And of course, this is the inverse of this. So if you have this function and then apply its inverse, it'll get rid of it. Done. Okay. Next question. Solve for v1. This one's kind of easier, isn't it? So what function has been applied to v1? Well, the multiplied by c1 function. So you say, okay, to get rid of the multiplied by c1, I should do the inverse of multiplying by c1. What's the inverse of multiplying by c1? And again, you have to realize c1's just a number. So like, what's the inverse of multiplying by 7? Dividing by 7. What's the inverse of multiplying by 3? Dividing by 3. What's the inverse of multiplying by c1? Dividing by c1. It's just a number. So, and do it to both sides. It'll get rid of the multiplied by c1, so you'll just have v1, and then on the other side you'll have c2, v2 divided by c1. Okay. And we have some more. So here's solve for m. What's the issue here? You're looking for m on its own. This v is kind of, isn't it? It's kind of, it's in the way. So what's been done to m? It's been divided by v. Yeah? Like even if I was kind of really showing off here, not showing off, but m over v is the divided by v function applied to m. So how do you get rid of that function? How do you get rid of divided by m? By v. You apply its inverse. What is the inverse of dividing by v? Multiplying by v. And to do it to both sides, you get rho multiplied by v is equal to m. Done. Solve for I. Now here you have to do some PEMDAS. So this is kind of little algebra things that will catch people. So RI squared, is it RI squared? Or is it R by I squared? And if you do PEMDAS, so there's no brackets here, E is exponent is the same as power. So you do the power first, so it means this one. It doesn't mean this one. Okay. So what that means is we're looking at working from the outside, because remember we're running backwards. So if the squaring is done first, after that the R is done. So what we have to do here then is get rid of the multiply by R. What is the inverse of multiplying by R? Because we want to get rid of the multiply by R. What's the inverse of multiplying by R? Dividing by R. Do it to both sides, you get P divided by R is equal to I squared. And now we're going to have a little subtlety coming in here. Now if I is positive, this subtlety doesn't matter, but there should be two solutions. Okay, we're trying to get I on its own, it's squared. What's the inverse of squaring? Square rooting. So do it to both sides. Now again, this is just a single number. Now funnily enough, if you put the square root on both of them, you get the right answer, but I want you to think of this as a single number, and we're going to put the square root, all of it. And then it gets rid of the I, or excuse me, it gets rid of the square, it's the inverse of the square. But the subtlety is there's two solutions, plus, minus. That's a little subtlety. Next one here, solve for g. Well, you want to get rid of the square root. That's the thing on the outside. What's the inverse of square root? Square. Now you'll have to be able to see the thing you want to get rid of. In this case, square root. It's a function, and know what the inverse is. The inverse of square root is square. So square both sides, and the square will get rid of the square root. You'll have g divided by L. And I just said it there, divided by L. That's stopping g from being on its own. So I want to get rid of that divided by L. What is the inverse of dividing by L? Inverse of dividing by L, multiplying by L. Do it to both sides. So it's the same principle the whole way through. The only thing actually is the whole time I'm ending up with the thing I want on the right hand side. It doesn't actually matter. Like if that's equal to that, you can swap them. I'm not moving them. Like if A is equal to B, B is equal to A. That might be nice. If you're in a country that reads from right to left, all your things will end up like that. Small little thing here. When solving equations that fractions, you want to get rid of the fractions. You want to identify fractions as something you want to get rid of. And the way you do it is as follows. So you see this 1 over 2 plus x? This is equal to 1 divided by 2 plus x. So if you want to get rid of that 2 plus x, you have to do the inverse of dividing by 2 plus x. So in this fancy notation, it's a bit mad. I know it's only I use this notation. So it's 1 apply the divided by 2 plus x function, you get this. So you have to apply the inverse of divided by 2 plus x, which is multiplied by 2 plus x. Now there's an argument here actually to get rid of the 4 first. And I actually will do that because you want to work from the outside. Maybe I won't, just to show you what happens if you kind of do things in a slightly different order. So say we want to get rid of this divided by 2 plus x. Then, and you can say, oh, but you're getting rid of the x. Don't worry about that, the x won't disappear. So you got divided by 2 plus x, the inverse is multiplying by 2 plus x. Now what you have to recognize, if you don't get rid of the minus 4 first, which is slightly easier, is that on the left hand side you've got a sum. And when you multiply a sum by something, you multiply both things, both of the terms. Okay, so just be careful there. So I'm going to apply I'm going to multiply both of these by 2 plus x. So the 2 plus x by 1 over 2 plus x will get rid of the divided by 2 plus x. I'm just going to be left with 1. And then I got the minus, and then 4 is multiplied by 2 plus x. So they're both multiplied by 2 plus x. And multiplying the 1 over 2 plus x by 2 plus x gets rid of the divided by 2 plus x. So you're just left with the 1. And remember to do the same thing to both sides. Now this question would be way easier if you got rid of the minus 4 by applying the plus 4 function to both sides. It'd be way easier. Now there's a little thing to look out for here. And there's a line that I wouldn't normally include. I'll just put it in pencil. So this minus business really, so if you look back at the laws, there's no subtraction. It's adding a negative. And really what's going on is, say, a minus b, it's actually a plus negative b. That's what subtraction means. And it might help us a little bit here to see what's going on in the next line. So it's 1 plus minus 4 times 2 plus x is actually what's going on there. That's going to help us in a minute. Okay, now where we are here is we don't really know where we are. So the obvious thing here is probably just to multiply out the brackets. Okay, so we'll do that. But here we see that it's minus 4 by 2 and minus 4 by x. Just be careful with the sign. Minus 4 by 2 and minus 4 by x. So we get 1 minus 4 by 2 is minus 8. And minus 4 by x is minus 4x. Equal to 5 by 2 is 10. 5 by x is 5x. So so if you do the onion on this and get rid of the minus 4 first, this is a way easier question. Now what we have is the issue we've gotten x's on both sides. And we want all the x's to be on one side. So we make a choice. We want the x on the left or on the right. Now lots of people want the x's on the right, and it's fine. But I'm going to just, for no particular reason, I'm going to get all the x's on the left. So I don't want x's on the right. I want to get rid of that. And this is minus 7. I don't want that there either. These are the things I want to get rid of. So how do I get rid of the minus 7? I do plus 7. And how do I get rid of the plus 5x? I do minus 5x. Now, if I'm really fancy here, I can write down different things, like I can do adding 7 to both sides after taking away 5x. And there's all manner of different things, but to be honest, you can just put a comma between them. So I'm going to add 7 and minus 5x from both sides. So here I got a minus 7. If I do plus 7, that's the inverse, that's gone. I got minus 4x, take away another 5x, that's minus 9x. I have 10 plus 7 is 17, and 5x minus 5x, the inverse, it's gone. And now what I want to do is I want to get x on its own. It's multiplied by minus 9. What is the inverse of multiplying by minus 9 is dividing by minus 9. And so I'll end up with x is equal to 17 divided by minus 9, and that's a perfectly good answer. Now, one of the things, just a little tiny bit of algebra here, is plus divided by minus is minus. So if you want, you could say this is minus 17 over 9. It's probably worth taking a scrap of paper and seeing how much easier this is if you do the plus 9 first. Okay. I'm a little concerned here. No, that's fine. Okay. Now this will be one for maybe you to try before the next lecture. So try this yourself now.